Okay, it's great to see everybody. Thank you. Welcome to the second day of the Comet Conference 2024. We had a fantastic first day. We're going to have an equally fantastic second day, I think. We got some great speakers in this session. The way that we're going to run this particular session, we're going to have Phil Robinson up first. He's going to be our first speaker. And then we're going to be having a coffee break. And then we're going to be coming back for another 2 speakers. So just a little bit about me, very short, brief intro about me. I'm Richard Scott. I'm currently leading a new startup called Modelizer, CEO at Modelizer. My second innings in terms of technology innovation. Previously had a little go 20 years ago developing mobile applications, product known as Priority One, now known as FieldView. We're going to be talking about digital twin technologies today, and I think what's going to make this a little bit special is that we're going to get the perspective of real tier 1 construction companies and how they've implemented digital technologies and some case studies. It's always really great to hear from the point of activity, if you like, seeing this technology going into play and making a difference on projects. So we've got Phil Robinson, civil engineer, leader from Laing O'Rourke, talking first. He's going to be up in a second. And then we've got George Floras from Skanska, just after the coffee break. And then we've got Luke Holbrook from Enable My Team. And then we're going to have a panel session just after that. Okay, we'll make a start. So I'll invite up Phil to the stage. Phil is going to be talking about implementing digital twins and his experience in terms of offsite manufacturing and a real case study around a bridge project, I believe, right? Yeah. Fantastic.
Very much. Thank you, Jason. Morning, everyone. Thanks for having me in today. Really.
Oh, just a question. Yeah. Okay. Sorry, just getting that a bit long. Just didn't get the rehearsal quite right. If you want to have your questions are going to be at the very end of the session. You can scan the QR code here. You can you can put your questions in, and then we'll be presenting them at the end of the session during the panel session. Okay. Thanks. Sorry.
No worries. Just wait for everyone to get that. Right. Keep going. Right, so thanks for having me this morning. Basically, I want to talk to you about our application of digital tools and product-based delivery of bridges. Just a bit about me to start, just to give a bit of background. I spent 10 years as a designer when I first started out in my career. Very lucky to work on some quite prestigious buildings, Palace of Westminster and St Pauls Cathedral, before moving into major infrastructure projects and design. One of the things that, the slide build hasn't worked. One of the things that I'm really passionate about is drawing. And so it doesn't matter whether I've been in the design process for 10 years or I've been in the innovation part of Laing O'Rourke's business for 10 years now. I've always sketched and always drawn. So it's really important and passionate. So if anything I can do today is if everyone can go home and back to your businesses and encourage people to practice drawing, get on drawing learning skills and courses, our engineers of tomorrow need to keep that skill going. So please take that back away with you. It's the least I can do today. But what I'm here to talk to you, Dave, probably follows on quite well from what Jack was talking about earlier on. If my children at home can sit there and use a tablet to get instructions based on a model of something that they're building in Lego, or not me, but someone might be able to go online and configure their next Aston Martin, or someone can actually go online and look at their wardrobe and how they configure that wardrobe and how they customize what they've got on screen in front of them before they buy it. Why in our bridges space can't we look at design automation in a similar way? So how do we use those tools to bring to life what we're doing in the construction industry? So we've been on a journey which has been known as digital bridges for the past 10 years. And there are 2 key parts of that. One is around the tools, the digital tools themselves, but the other is around the actual products. What was shown earlier on around sort of some of the watches that were shown on the configuration, the option selection screens and some of the configurators, they only exist because people have taken the time to productize what they actually have created. In the construction industry, we have concrete and steel, and we love to manipulate those to any shape and form we like to make for every single project. So we actually haven't really productized what we actually use. So you've got to go to the effort of actually productizing things to actually enable some of the technology that we're talking about. So what that's allowed us to do is to start thinking about what does that do to us for the design process. So currently what happens in a bridge design is you have a bridge location. You then get asked by a client to explore different options for that bridge. And the designer has a very small budget and they go along and look at 3 different options because that's all they can afford in terms of time and budget to do. And then they make a selection based on someone pricing and programming just those 3 specific options. And usually they pick the cheapest one. And then someone comes along and says, well, could we be more efficient in this way and build this in a modular fashion? And by that point, you've probably already locked in parts of that design that are actually quite bespoke to that location or the geometry you've chosen. And so it's very difficult to split it up again. And also when it comes to approvals phases, you might have pre-agreed something with the client, the local planning authority and other things that you can't now unlock. It's difficult to unpick those processes. So it tends to start falling down again if you try and modularize things at a later date. So we're trying to flip that. And what we're trying to say is if you've actually productized your components, you actually have a library of products. You can pre-approve those with your clients. So you're not taking through the approvals for each bespoke bridge. You're actually taking through a product library through an approvals process rather than actual instances of those configurations. You can then look at all the locations across a project and apply those products to all those locations and use digital configuration tools to actually really quickly configure those and explore dynamically what the cost, carbon and program implications are of those decisions that you make in design. So you're actually making design decisions informed by cost rather than just costing your design. And therefore you can then make your selection. So that's reordering that process is what these tools give us the opportunity to do. So I want to firstly talk to you about the digital kit, the modular kit of parts, and then I'll talk to you about the digital tool. When we productize things in the construction industry, you can't just do that as a designer in isolation. We've worked really closely with our designers, but we also have our own internal business units, which have been able to look at how we manufacture our precast concrete components, how we actually transport them to site, how we then install them on site and lift them in with cranes. So how do all of those things come together? So what you might be able to design something that works for the permanent load case, but how do you lift it out of the mold in the factory? How do you transport it? All those things have to be built into a sort of set of constraints for the product. Look at which one is the most critical constraint, and that becomes your leading defining value for that product and that dimension or that weight. But you have to go through that process. You can't just do this in isolation as any one of those individual parties or the designer or the client. So I want to take you through one of the things that we've developed, which is basically one of our modular bridge abutment shell solutions that we've been using across a number of projects now. I'm very proud to have won some offsite awards last year for the development of this. We've been deploying that across all sort of 3 major infrastructure groups in terms of roads, rail and high-speed rail. Currently installing bridges on the M25 at Junction 10. Sorry for those that the road was closed over the recent weekend, so any problems caused, apologies. But we hope that what we've done there is actually build things in a faster, more efficient way to actually minimise that disruption. So that's the value, hopefully, of what we've brought to that. And once you've got a component and an interface, you can start to look at how do I then add the next set of components to that follow that same interface. So a bit like your Lego blocks, in going back to the very first slide, how do I actually take the interface and then play with that to create different shapes and forms rather than just having one something that's very variable. It's how do you create the maximum number of configurations but with a minimum number of product variations, so to actually get that efficiency through the manufacturing phases. And hopefully this video will play. So basically this is a video of our abutments going together on the HS2 project. So what you can see on the right there is the abutment with all the precast shells being installed. We drop those onto the foundation. We then lower in some prefabricated column cages that drop down the center of those elements. And then we fill them up with concrete. So rather than standing up a load of reinforcement, fixing it all manually, then standing your shutters up, then putting all your temporary works to prop all of that lot before you can actually pour the concrete and all the time and labor associated with that, this allows us to build really, really fast. And when you're in an environment like the M25, when you're in a central reservation trying to build something and the traffic's going past you at 50 mile an hour, for those who don't stick to the 50 mile an hour, it's bloody scary to be stand next to that traffic at 50. So the least time you can spend there, the better, definitely from a safety perspective. Some of the visuals have gone, but so some of the benefits from that are that we basically have what would traditionally be for that abutment, a 11-week, about 3 months construction period, but we're actually doing that in 3 weeks, and we're doing it with a team of 6 people. So that was done during the height of COVID, that video where we basically were limited on the staff that we could actually have around on sites and things, so we wouldn't be able to keep up with programs. So it's a significant labour reduction. The carbon reduction is a bit, it needs explaining a little bit. So basically what we've done is by shortening that time, we've reduced the amount of prelims and put cabin setups, the journeys to site. There's a whole series of things we have to think about when we think about the carbon calculation. It's not just volume of material, it's the type of material and it's the way you put it together. You have to think about the complete package. And as that speed of construction means we're about 8% less carbon in our abutments constructions. That then leads through to prelim savings. And we obviously then get the benefits of fewer people on site for less time doing repeatable processes, so it's safer and the quality can be improved. So even though, sorry about the words on this, they seem to have gone awry. Even though there's more concrete in the abutment solution, there's less carbon. And that's a really important part to think about. We're in an industry at the moment where there's a lot of analysis tools that are out there that basically designers are using to pare every last little bit of material out of a solution without thinking about how you actually build it. And as designers and contractors, we have to work together to come up with the best solution holistically, not just with one blinkered view. Well, that's not come out very well, has it? So basically, this is meant to show traditional construction back to modular construction. Basically, leads to about 50% reduction in time, and that's generally due to the program associated with the abutment construction. And across the M25, this would also what was this meant to show was that basically there was a 2-year program that through the abutment construction, what we've been able to do is take 6 months out of that program. And that's through the combination of individual bridges being faster, but then that's also allowed us to then completely reorder the sequence in which those bridges were put together. So the critical path overall, even though there's a small saving on each bridge, it completely then flips the whole critical path of the whole program. So that's a bit about the product development and the benefits of the products. Wow. So I'm going to skip to the video, which I'll hopefully play. Right, so this is the Digital Bridges Toolkit. So this is a demonstration of the digital tool we've developed to configure these bridges. So you can log into an online platform, you can put some base information in about yourself and the project, you can drive the geometry of the bridge that you're trying to configure, and then you can get to see a preview of that bridge. So based on some really minimum inputs, we can get a bit of a skeleton of what we're actually trying to build. Based on those minimum inputs, you say, what decisions can I make next? Well, I can start to choose my beam sizes. And I can start to then see how hard that structure is working at a very early stage in the design process. And we start to add detail to this schematic model. We start to break it up into the sections and volumes that would suit our products as we deliver this bridge. And there's always that ability to review what decisions you've made and visualize them in reality. We can then do the same with the wing walls. So we've done the bridges, we've done the abutment, the main bridge span, we've done the abutments, but you can also look at the wing walls and how they relate to the bridge itself. So there's no products in this yet. This is just establishing what is the shape and form of the bridge that you'd like to create, but it's constrained by the rules that attain to our products. Following that, we can then start to add in the real volume of the real concrete and the real beams and the real products into the model. So here we start to see the deck come together with the concrete slab itself, the permanent formwork that sits between the beams, and what's also important is the interfaces. So it's not just the products, it's the in-situ bits that stick all this together. They also have to be productized because to understand the rules about how the interfaces work. We can then also put different parapets in there. So these aren't products that we make, but they're from the supply chain. So how do we actually link with supply chain partners to bring all these products together into a complete bridge? So that is 40 minutes worth of configuration to get to this point, inputting that data. And you can see it's right down to nuts and bolts level of detail on the bridge and those parapets. So it really does speed things up. From a design perspective, we looked at that with our consultants, and they did a detailed study for a bridge, and that was 125 days worth of design engineering input, and we replicated that in 4 days. So the ability to test more bridge configurations to then explore cost, carbon, and program associated with each one in a very short space of time is now possible. And with the advent of AI and machine learning, when we move that on a step, that's then about, rather than then manually configure, putting all the data to try and explore different options, it's then saying, go and find me the fastest one, go and find me the cheapest one, go and find me the one with the lowest carbon, and then we start to make real selections based on what value is. So the model is dynamically linked to drawings that automatically output from there. It's dynamically linked to cost, carbon, and program data. So we get all of that information out. And really what we're saying is that this again has the opportunity to reduce design durations by 50%. We think it can do more than that, but obviously there's planning processes to go through. There's other things that slow the process down. And what we're trying to do is work with clients now to say, well, if we're designing using automated processes, how do we tie in with your systems to allow you to do maybe automated approvals and automated reviews? So the what next, to wrap up. So we're adding in more capability into the tool, so more products. So what you saw was concrete beams. We'll have steel beams in there very shortly and multiple spans. So we should be able to respond to about 80% of the bridges that come in. We're never going to achieve the whole thing, the whole bridge market, because the long cable stay bridges, the architecturally expressive bridges, the ones that demand that human intervention and the bespoke nature of bridges, you can't productize that because that requires that level of intervention. But the 80% of bridges that cross our major road and rail networks we can adopt that approach with. We're looking at new product systems, so it's not just the shells on the screen there. There's different abutment systems, one being a flexible abutment that I'm quite happy to talk about another time. And we're also looking at different materials in terms of basalt, rebar, and geopolymer concretes. I've put this up here because I know there's a Q&A session afterwards, and so some of the key areas that I often get asked questions around are on these subjects. So if anyone's got a question or was thinking of what to ask, quite happy to field them on those subjects. Also, anything else you'd like to talk about? That's not work right. But what I wanted to say with this was, we have design, manufacturing, assembly teams, but we don't do this on our own. We do this across a huge range of input from other parts of our business. And also, that's just looking internally, but externally, there's a huge number of people that have been involved in this process. So the key message really to end on is that if you want to go fast, go alone, and that might be all right at the start of a project. But if you want to go far with innovation, you have to go together and utilize the knowledge and expertise that is within our industry. And with that, thank you very much. Thank you.
Thank you very much, Phil. I think that's absolutely fantastic. I remember reading when Ray O'Rourke was leading Laing O'Rourke some time ago that he had this vision that construction sites of the future would become assembly facilities. And I think, seeing that case study there is an example of seeing that in the real world and the benefits that you get from it. So fantastic. And just a point, the slides, the problem that we had with the slides there, absolutely nothing to do with Phil and Laing O'Rourke. It's to do with the conversion between PowerPoint and Google Slides. So I think, just to want to point that one out. So thank you very much, Phil. We're going to break for coffee now. We're going to return at 11 o'clock for the second and third sessions. Cheers. Bye-bye.